This is algae growth and the role of nutrients.
What up, little microbes? We are the Algae Hustlers. Welcome to our presentation, Algae Growth and the Role of Nutrients. My name is Jeremy and I'm the data analyst slash producer slash team lead of the Algae Hustlers, as you well know it. Now, before we start the program, I want to first go over some quick housekeeping items for you. We're going to start off with the introduction slash hypothesis slash method slash results slash conclusion and whatever the heck is next after that. Throughout the project, what stood out to us was that too much algae is bad for the environment. But what if you add some nutrients that could potentially lead to algae growth in lake water? We have yet to know. That being said, let's put our dear colleague Diana on the line and see what she has to say about this. Diana, walk us through what this project is about, starting with our research question.
Our research question is, what is the effect of adding both nitrogen and phosphorus to water on dissolved oxygen and pH levels? And how does this impact algal growth compared to when nitrogen and phosphorus are added separately? Our hypothesis: if we add nitrogen plus phosphorus to the water, then the DO and pH levels will increase, leading to more algal growth compared to nitrogen and phosphorus separately, because they both work together to enhance nutrient availability and stimulate algal proliferation, promoting faster growth and denser populations in the aquatic system. Our if-and statement: if we input 200 milligrams per liter of nitrogen and 50 milligrams per liter of phosphate together to the water samples collected from Little Lake, then we expect to observe a corresponding increase in DO and pH due to algal growth.
So this is the key figure that we got inspiration from for our hypotheses. This is from figure 9-8 from the limnology book, and it's what we expect to see. Both nitrogen and phosphorus are growth-limiting nutrients, and each nutrient by itself stimulates an average doubling the growth. When added together, they produce an average of 5-fold increases. So now on to our methodology. For materials, we have 12 BOD bottles. Each bottle is 300 milliliters. We have a pH probe and DO probe because we're measuring algal growth indirectly. We have DI water, and we have two nutrients, which are nitrogen and phosphorus, and our stock solution. For experimental procedure, our first step was to calculate how much phosphorus and nitrogen we were going to add. So the ratio of N to P is 10:1. So after doing the calculations, we determined that phosphorus, we were going to add 0.12 milliliters, and for nitrogen, 1.2 milliliters. Our second step was to actually prepare the stock solutions with our nutrients. And we had 3 BOD bottles with nothing added, which was which were our control. We had 3 with phosphorus, 3 with nitrogen, and 3 with both of them with N plus P. And then we placed our BOD bottles at Little Lake. On day 1, we set them at 8 a.m. and we took initial pH and DO measurements. For day 2 and 3, we took pH and DO at 8 a.m. and 5 p.m. And then lastly, we had to evaluate results and discuss uncertainties.
Thanks, Diane. Now, as part of our experiment, I had to consult with my team to see if it was possible to do a preliminary test of all the equipment we use and test them out with all the samples. And guess what? It worked! So, without further ado, here is our preliminary trial. Pay attention. It all started on April 19th, where my group took all the materials in a bucket and went down to Little Lake to see the moment of truth. By then, we have already calibrated all of our pH and DO meters with the proper buffer solutions. However, throughout the process of collecting our data, we ended up calibrating our meters with DI water. What? Which turned out to be something we were not supposed to do, but we ended up getting the data we got anyway, according to this table. For this step, we conducted a baby trial for all the samples for at least 7 days, with mornings and afternoons in between, starting with nitrogen, phosphorus, and N plus P combined and the control. Again, I want to point out, this is just a preliminary trial, or as my group calls it, a baby trial. What? By then, we had to come up with plan B, because otherwise, it's over. So to save ourselves some time, our group decided to not start over, but to rather recollect data, the pH and the DO, for all the samples for 3 days. But this time, we only took into account the results from day 2 and day 3. More on that later. Anyway, we sent out Diane and Diana to help me out with this process, and they did. And this is our new data that we got collectively from our first trial. Cool, right? But then we said, wait a minute, we can't just rely on one single piece of data per sample, right? How about we collect a series of data of that same sample in order to get a range as to how fast and how slow the pH and DO is changing, right? So we triplicated all our sample bottles, which we now have 12 bottles based on our materials. After surviving this risky trial through wet clothes and stress, we now have our results. So we had to ask ourselves, how do we compute all of this? How do we make sure our viewers understand our data? As part of our data analysis, we were more concerned about the DO levels not having an effect at all. So with that being said, we used the following equation to calculate the average levels of DO per sample by dividing the change in DO over the change in time in hours times 0.3 liters, which is our bottle size, and that will give us the average level of DO in milligrams per hour. But I want to point out that our values for DO were different for each nutrient, but our time of duration remained the same for all samples as 9 hours. Now, for the second phase of our data analysis, we used a statistical tool called t-testing, which is used to evaluate whether a single group differs from a known value, whether two groups differ from each other, or whether there's a significant difference in paired measurements. And our dependent here is our controlled base. With that being said, our two comparisons fall within ammonia and phosphorus and N plus P, which is a combination of both in respective quantities. We successfully completed the t-test of all our samples, and this is the data that we got. You can see here that the p-values of all our t-tests are lower than 0.05, which is good news because in the world of stats, if it's less than 0.05, then your data is statistically significant and reject the null hypothesis. Using Python, we derived this graph where it shows the DO results by each sample. We took into account the normal distance and delta DO as our variables. Based on this graph, you can see that nitrogen and N plus P stand out to have a higher normal distance than the rest of the samples. For our third phase of the data analysis, we derived these graphs that show the average DO levels for day 2 and day 3. By this graph, you can tell that almost all of our samples have margins of error. What does stand out to us is that nitrogen came out on top for day 2, while on day 3, N plus P came out on top. Doesn't that sound familiar? Isn't that our hypothesis graph? So are we saying that on day 3, we're proving our hypothesis right but not day 2? More on that later. So by summing up all the phases of our data analysis, we can infer that although all the treatments did produce DO and our initial expectation was that nitrogen plus phosphorus do produce the most of the distribution fell near each nutrient addition. Which leads us to our conclusion. Finally, how do we wrap all of this up? As mentioned earlier, all of the nutrient treatments did produce DO, and we expected N plus P to boost algae growth more than N and P separately. And one hypothesis was not supported, which is the Horton diagram from the linology textbook, and another one is an increase overall. And I know you might be thinking, is this it? Is that supposed to be a good thing? Like, where are we heading with this? We'll leave that to our Q&A session after this.
A huge shout out to the Algae Hustlers team and Dr. Butel for helping us get through this semester and for making this project possible. Thank you for watching this fake broadcast.
Like we always do about this time.
This program is brought to you by Algae Hustler Productions. Thanks for watching.